Welcome to Lesson 66, Similar Figures in the Real World. So you've been looking at proportions and then similar figures in the last two chapters. And Lesson 66 is a pretty easy lesson, but an interesting one, because it just makes a few interesting points about how you would rescale things, in other words, and create scaled versions of various things, and obviously use proportions and similar figures to do so. And there's many concrete applications of this, but the example they give here is someone that wants to create a scaled plan of their living room. A living room that has a couch and two seats, and you see the couch here and you see the two seats here, and they're reproduced in this model here with the couch here and the two seats here. Now the scale is 7 feet 1 inch. Okay, so a 7 foot long couch is in the plan is 1 inch long, and then you're told that the couch is 3.5 feet wide, and the question is, well, how wide do I draw it on the plan? Now that's not a difficult problem, but they go through it systematically and show you the arithmetic to do so. And that's on the flip side here. So because of the definitions of similarity using the characteristic of proportions, you know that the width of the drawing of the couch relative to the width of the real couch should equal the length of the drawing divided by the length of the real. You know that. And so if you know that, anyway, they do the arithmetic here, and it implies multiplying by 12 or 1 foot. That's 12 inches. So if you calculate how many inches there are in 7 feet, it gives you 84 inches. So the ratio 1 inch on the drawing equals 84 inches in real life, or 7 feet. And so how wide should the couch be? If its length is 1 inch or 84 inches, it would be half that, obviously, 0.5, and that's solved here. Okay, so there's couches and things to draw on a floor plan. You can also look at states, and they give the example of Colorado. Where's Colorado? Nice rectangle. So you know that the width of Colorado in real life divided by the width on the map should be the same as Colorado in real life, the length divided by the length of Colorado on the map, and so on. So, and there's a bunch of practice exercises related to that. I just want to note that I've circled almost everything, except, yeah, actually, I think you should be able to do this proof too, okay? So I've circled virtually everything, and including this one, and there's two at the end as well. Okay, this one's very easy, and this one is very similar to the other one. But I like to have a go at it. You know that with a rhombus, the diagonal bisects, and you can use a theorem property to indicate that these two are the same. And so I think you'll be able to demonstrate that triangle DPB is isosceles. Maybe leave those two to the end, these two rhombus proofs to the end, and do them at the end of your hour if you have time. And if you have trouble with them, or if you don't succeed, we should look at them during the day. Thanks. Bye.